Let us consider two more scenario analysis, again on problems that we've already solved. The first one is the problem where we painted floors of some rooms, and we had rooms numbered from 1 to 6. We had length and width for that room, and we had a paint that we now know we could have used data validation and VLOOKUP on. So we had a paint saddle in. We had the amount of paint that is being used for 1 square meter, 0.52 liters, and a price for that paint, 47.8. We also had a wage for a worker who was painting that floor, and we calculated the area of the floor, which is length times width. We calculated the amount of paint, which depended on area and the amount of paint that we use for 1 square meter, so the amount in liters of paint. Then we calculated the cost of materials, which depended on the amount and the paint's price, and the amount of paint liters and the price of 1 liter of paint. And we calculated the wages, which depended, and now the point was to use the area, because how many square meters you paint, that much wage you get, and we used the wage rate again. Now all these calculations done, again I'm going over it quite quickly, but again we can always refer back to the original problem, and this is not the key thing here. So area, amount of paint in liters, cost of paint, cost of working, and the total cost, which is the sum of the two before. And now below here, all the sums, all areas or liters or dollars for paint, all dollars for wage, all costs together. And now this problem has been modified very slightly. Namely, we have now something called a price inflator, which says how big is the inflation in this project or in this society at large, because when we raise this inflation, we are actually have done such a thing that we've taken the price of the paint and the wage that we're paying for that worker, and now we're not using them directly, but we have calculated a current price which takes the initial price and, if necessary, makes it bigger by inflation, and the current wage which takes the initial wage and makes it again bigger by inflation. So if we make inflation 1,1, now the prices have gotten bigger by 1%. Both prices together, the price of paint and the wage. So once again, this is just a multiplication of the initial price and the inflation of 1.00, and this wage is the multiplication of initial wage and the inflation 1.00. And actually, for the wage cost, this new cell is used, and for the paint cost, again this new cell is used. Okay, and now our first scenario analysis goes as follows. We want to make this inflator from 1.00 to 1.01. So we're going to, sorry, it's not point, but it's comma. 1,00, 1,01. So we're going to actually raise the inflation in the entire system. All prices are going to be raising by that inflation, and we're going to raise it by 1%. So when we copy them together, we can get this inflation up to, let's say, 15%. Okay, and now what we're interested in is the total cost. So it's equals, and that final total cost, it's the cost, we could say, the cost of our entire project. Now let's make a data table. Let's select it all. Let's give the command data, what if analysis, data table. And once again, this total cost has been linked to our model. Now, since these numbers here are in a column, we will use it as a column input cell. We do column input cell, and the column input cell is our general inflation. So we're changing the general inflation from 100, 100, the base number, to 14%, 1,14. And we're looking at what happens to all the costs together, our final cost, what it all costs for us. Let's click on OK, and here it is. Okay, we see clearly that the price of our project goes up. It goes up from 4,950 to 5,643. But now let's check out something different. Let's check out what happens, when the inflation hits us by 1, 2, 3 and more percent. Let's see how much, by which percentage did the cost go up. Let's see that. So we have to write down something like this. We're going to write equals, and we will take the current total cost and divide it by the first total cost. Here in the first cell we will divide it by itself, so it will be 1. And now we will take the dollar signs and make the first total cost stick. So when we now copy it, what's going to happen is it's going to always take the current cost and divide it by the first cost, which means that, as we see, for instance in the third scenario, the costs have gone up to a multiplicator of 1,03, which means the costs have gone up 3%. And now the point we're trying to make with this scenario analysis is that if we raise the general inflation by 3%, all the costs together, the total costs, go up by 3%. So since all the costs consist of only material and wages, and when the general inflation raises both of them, then the total cost goes up by the same percentage. And now let's consider a competitive scenario in which things are different. Namely, let's now inflate only the paint. So there is no general inflation. Sorry, we're inflating only the wages. There's no general inflation. The materials or capital investments stay the same, but our human costs go up. Let's see what's happening. We write for human costs 3,62 and 3,72, and we continue this pattern so that the cost of a wage goes up to 5 per square meter. And we are interested in, again, the total cost, I16. Now we're going to make a data table. Let's select it all and give a command data, what if analysis, data table. And since again those wages here are in a column, it means that we are using column input cell. And now, of course, we have to be careful. We're now changing the base wage, which means base price for paint is the same. Base wage raises, and let's click OK. And here we see the total costs going up. Now let's see how many percentages did our wage raise? We have to write equals the current wage divided by the very first wage, and we're fixing that first wage with dollar signs, and here it is. It's in the first, at first it's 1, and when we copy it, we see that it's the different percentages by how much our wage has gotten higher. We can actually even select it, do a Control 1, and turn it from number into a percentage, so that we nicely see that it goes up. 100% is the base, and we're up 113% midway. In the end, we're up by 138%. It raised from 3,62 to 5,02. Okay, and now let's consider the total costs. We once again take the current cost and divide it by the first cost. To fix the first cost, we're taking the dollar signs and fixing the first cost. Now we can copy and calculate the costs. We can once again select it all, do a Control 1, and take it into a percentage. And now we can see that while the wage went up, let's say 13%, the total cost actually went up only by 1%. While the wage went up 138%, the total cost raised only by 4,92%. So the reason for that is that total cost consists of two costs, material and wages. And here, in our case, the cost of material exceeds wages. But more importantly here, we see that since there are two parts to costs, when we change only one, the total cost go up by a different percentage than this one, because there is the other, the paint as well as wage. We change only one, the total cost go up by a different percentage than the percentage by which the wage went up. If we change both by the general inflation, then the total costs go up by exactly the same percentage. So just one more time underline here that in this case the cost of material was considerably higher, and that's why the wages went up by a higher percentage than the total cost did.